So let's start with the universe. Let's rewind time to the very beginning. Before stars, before planets, before even space and time. Everything that exists today was once compressed in a single point, unimaginably hot and dense. Then, in an instant, it changed. This moment is known as the Big Bang, the event that marked the birth of the universe around 13.8 billion years ago. The Big Bang wasn't an explosion in space, it was a sudden expansion of space itself. Pause a moment and let that sink in. In a fraction of a second, the universe inflated at an astonishing rate. Time began, space stretched, and from this burst of creation came the very first ingredients of the cosmos, pure energy, which cooled and condensed into subatomic particles like quarks, electrons, and other such particles. As the universe continued to expand and cool, these particles combined to form the first atoms, mostly hydrogen. Then gravity, the invisible force pulling everything together, began to work its magic. Over hundreds of millions of years, clouds of gas collapsed under gravity's pull, igniting the first stars. These stars were enormous, brilliant, and short lived. Deep in their cores, nuclear fusion transformed simple elements into heavier ones like carbon, oxygen, and iron. When these massive stars died, they exploded in supernova, scattering their contents across the space. These explosions seeded the universe with the raw materials needed to form new stars, planets, moons, and eventually life. Every atom in your body, every carbon atom in your cell, every oxygen atom you breathe was forged in the heart of a dying star. In a very real sense, you are made up of stardust. Galaxies began to form, enormous islands of stars, gas, dust, and dark matter swirling through the cosmos. In one such galaxy, the Milky Way, a solar system took shape about 4.6 billion years ago, or 460 crore years ago. One of its planets, just the right distance from its star, developed the perfect conditions for life. We now call it Earth. Life began simply. Tiny single-celled organisms that evolved over billions of years through mutation, natural selection, and changing environments. Life diversified into astonishing variety we see today. From bacteria to forests, from whales to humans, creatures capable of wondering how it all began. All life is made up of cells, which are made up of molecules, and which in turn are made up of atoms such as carbon, nitrogen, oxygen, and many more. From vast galaxies to microscopic cells, this is the story of how the universe became us. Now let's talk about atoms. Have you ever wondered what you are really made up of? Not just in a philosophical sense, but physically, fundamentally. Everything you see and touch is made up of some basic building blocks called atoms. Atoms are unimaginably small. Billions of them can fit into a single grain of sand. They are constantly in motion, vibrating and humming with invisible energy. And while they may seem simple, they hold the deepest truths of our existence. Atoms are the foundation of everything. Mountains and rivers, trees and animals, your body and mind. Is something amazing. The atoms you are breathing right now might once have passed through the lungs of a dinosaur. They could have floated through ancient forests, drifted across deserts, or spun through the air in ancient cities. The same atoms may have been part of Cleopatra, Buddha, or Leonardo da Vinci. Through atoms, we are connected to every creature that ever lived. But atoms don't just build life, they build the universe. As I said, the atoms in your body were born inside exploding stars billions of years ago. Those stellar explosions scattered their ingredients through space, forming new stars, planets, and on at least one planet, life. Despite their small size, atoms are not simple. Each atom is made up of even smaller parts, protons, neutrons, and electrons. These parts interact with forces and energy fields to form matter as we know it. There are only about 118 known types of atoms called elements, yet their combinations are endless. Two hydrogen atoms and one oxygen atom make water. Arrange carbon atoms one way and you get graphite, rearrange them and you get diamond. From snowflakes to solar systems, the universe uses these basic ingredients in limitless ways. So the next time you look at someone or your own reflection, remember you're looking at atoms, tiny particles with a history that stretches back to the beginning of the universe. Through them you carry the past, inhabit the present and touch the future. Everything is atoms, and in those atoms lies a quite powerful truth. We are all deeply, invisibly connected. Now let's talk about multiverse. What if our universe, the one with Earth, stars and galaxies, is just one bubble in a vast cosmic bubble bath? That's the idea behind the multiverse. The possibility that many other universes exist, each with its own laws of physics, its own stars and planets, and maybe even different versions of you. So, the key ideas in the multiversal theory are: first, infinite universes. There may be an endless number of universes, each slightly different from the next. Parallel universes. Some could resemble ours very closely, with similar histories and people, but with tiny changes like you choosing tea instead of coffee. Third, different physics. Other universes might be drastically different, where time flows backward or gravity is too weak for stars to form. Fourth, quantum choices. Some theories suggest that every decision causes the universe to split, creating parallel outcomes for every possible event. So let's discuss briefly about various scientific theories that support the idea of multiverse or that predict the multiverse. So the first one is the quantum mechanics many worlds interpretation. It was proposed by U. Everett in 1957. This idea suggests that every quantum event spawns multiple outcomes, each in its own universe. Instead of one reality, all possibilities unfold across parallel branches. Second is cosmology's inflationary multiverse. From cosmic inflation after the Big Bang proposed by Andre Linde and others in 1980s, this theory suggests that inflation created countless bubble universes, each potentially governed by different physical laws. Third idea comes from string theory's landscape multiverse. String theory predicts around 10 to the power 500 possible solutions, each representing a different universe with distinct physical properties shaped by extra dimensions. Fourth idea is from brain cosmology's parallel brains. In M theory, a version of string theory, our universe is a 3D brain floating in higher dimensional space. Other brains may exist as parallel universes. Collisions between them could trigger big bangs. And fifth idea is mathematical universe hypothesis. It was proposed by Max Tegmark. This idea suggests that all mathematically possible structures exist somewhere. If it can be described logically, it exists physically. So let's end this with a basic understanding of the theory of everything, a search for unity. Imagine if one idea could explain everything, from the tiniest particles to the motion of galaxies. That's the dream behind a theory of everything. A single unified framework for all forces and matter in the universe. Right now, two major theories govern how we understand reality. General relativity explains gravity and large-scale structures like planets and galaxies, while quantum mechanics explains how particles like electrons and photons behave at the smallest scales. Both are incredibly successful, but they don't work well together, especially in extreme situations like black holes or the Big Bang. The math breaks down, producing infinities and contradictions. That's where the search for theory of everything begins. We have two leading candidates. One is string theory and another is loop quantum gravity. String theory suggests that the universe's fundamental building blocks aren't particles but tiny vibrating strings, like a guitar string producing different notes. Different vibrations create different particles. To work properly, string theory requires extra dimensions, 10 or even 11 beyond the 4 we experience. 4, which means length, breadth, height and time. Then second is loop quantum gravity. It takes a different route. Instead of adding dimensions or strings, it treats space itself as quantized, as made up of tiny loops or chunks, like a woven fabric. It merges Einstein's idea with quantum rules in a more conservative way. Both theories are work in progress with strengths and challenges, but they represent our deepest effort to understand the universe at every level and find the ultimate rules that everything follows. From atoms to galaxies, from the known to the mysterious, this is the story of everything and the story of you.